Right, we're going to find the derivative of y is equal to sine x, where x is measured in radians from what's known as first principles. Now, in order to do this, I'm going to use this Geogebra app, and this Geogebra app I'll put in the notes of the video for you to actually try yourself. So if we go to that Geogebra app, so here I have the green graph here. I have a graph of y is equal to sine x from minus pi by 2 up to about approximately 2 pi. Here I have a particular point. Any point on the curve will have coordinates x sine x at any particular point. So at this point is pi by 6. So it'll be pi by 6 sine pi by 6. But I'm just going to call this a general point. Now, if I draw a tangent line to that, that will represent the gradient of the curve. And that's what we're trying to do when we differentiate a curve. We're trying to find a formula, sort of a formula for the gradient of the curve, or the rate of change of the curve. Right, now in order to do that, I'm going to pick a point closer to P, but for the sake of being able to visualize it, I'm going to pick this point here by clicking this button here. If I click this point here, if I let this be x plus a little bit of x, and I call a little bit of x h, then the y coordinate of this will be sine of whatever that coordinate is, x plus a little bit of x, which is sine of x plus h. Then I can find the gradient by taking this distance and dividing it by this distance. Now this distance I can get by doing sine of, taking the y coordinates, sine of x plus h minus sine x, which is that distance. And this distance here I can do by doing x plus h minus x. And if I just click this here, I can show you that. So the gradient of the chord PQ is sine of x plus h minus sine x divided by x plus h minus x. Now obviously the x's cancel out and it comes down to sine of x plus h minus sine of x divided by h. Now, if I make this distance small, you'll see that the blue chord, this line here, will start to coincide with the tangent. Just look. So, sorry, going the wrong way. So moving it closer to it, you can see that the blue line almost is going to coincide with the orange line, which is the tangent line. Now, provided I make h very, 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 very small, so it doesn't be equal to 0, but it's close to 0, then that blue line will exactly coincide with the orange line. So the blue line will represent the tangent. So this, whatever this comes out to be, it will represent the value of the tangent. Now this idea of making h small is taking a limit as h goes to 0 of the gradient, and that will give me the value of the gradient. And if I do some algebra on this, which I'm going to do in a minute, I can actually find the derivative of y is equal to sine x. So going back to this, so there's a graph, there's a picture of what I've just done. But so I'm saying that the gradient is dy by dx is going to be the limit as h goes to 0 of sine of x plus h minus sine x over h. Now, using the compound angle formula, sine a plus b is sine a cos b plus cos a cos b. So a is going to be x and b is going to be h. This will now become sine x cos h plus cos x sine h. Don't forget to take away the sine x at the end, which is there. So all the red bit represents this, divided by h. Now, for small angles measured in radians, it has to be measured in radians, we know that sine theta will approximately be equal to theta, and that cos theta will be 1 minus a half theta squared. This is a result we've already done. So the limit as h goes to 0 will become sine x. Now cos h will become 1 minus a half h squared. So we're using this one here where theta is equal to h. Plus cos x sine h, well, sine h is approximately equal to h for small h. Don't forget to do the minus sine x, or divided by h. Now, if we expand this bracket here, we get sine x minus a half h squared sine x plus h cos x minus sine x, all divided by h. Now we'll see here that the sine x and the minus sine x cancel out, so that's good. And if we now take out a common factor of h from the numerator, that's going to give me minus a half h sine x plus cos x over h. Now we can cancel the h's because h is very close to 0 but not actually equal to 0. So we'll do that here. So the h's will now cancel out. So we've just got to take, so if h goes to 0, then minus a half h sine x, if h is very, 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 very small, will also approach 0. So small that we can ignore that. And therefore we can say that dy by dx will actually just be equal to cos x, which is the result that we used when we did the video on the graph. So the general result, if y is equal to sine x, then dy by dx is equal to cos x. So there's been a video to show you how to find the derivative of sine x from first principles. So more of a rigorous proof than rather just looking at a graphical method. I hope you've understood, and I'll remind you the Geogebra app that I use with this will be in the notes of the video. Thank you very much for watching.